Hi everyone, this is Mrs. Pettit. After spending the last couple of days learning how to find missing sides of right triangles using trig ratios, today we'll learn how to find missing angles of right triangles using those same trig ratios. So we'll be using the same acronym, that SOHCAHTOA, that you've already heard. As I've shown my kids, I like to write it in this fashion. SOHCAHTOA. They mean the same thing, right? Sine of an angle is equal to opposite over hypotenuse. Cosine of an angle is equal to adjacent over hypotenuse. And TOA, tangent of an angle, is equal to opposite over adjacent. I just like it in this format because it shows you exactly how the ratios need to be set up. So just starting off, we know how to find the sine of angle B. So if we start with our angle B, we want sine. So opposite over hypotenuse. So opposite over hypotenuse would be 25 over 65. If I want to find the measure of angle B, so now I'm looking for that actual angle measure, we'll rewrite with what are called inverse trig functions. So if I want to get angle B all by itself, I need to get rid of that trig function. We get rid of trig functions by using inverse trig functions. You'll notice on your calculators that over the trig functions of sine, cosine, and tangent, our second functions of what look like sine to the -1, cosine to the -1, and tangent to the -1. These are called your inverse trig functions. And trig functions and their inverses are basically opposite operations. So while taking the trig function of an angle gives you the relationship of the two sides, taking the inverse trig function of the relationship of the two sides will give you the angle measure. So if I take my original problem of sine B equals 25 over 65 and take the inverse sine of both sides, I get inverse sine of 25 over 65 equals B. If you have a calculator where you put the trig function in first, to use inverse trig functions, you'll do the same thing. If you have a scientific calculator where you have to put the ratio in first and then the trig function, you'll most likely do the same thing here for inverse trig functions. If you have any trouble at all, just try the steps above and see that you get the same answers and play with it a little bit until you figure out how your calculator in particular works. And if you have any trouble at all, reach out to one of your teachers. So I'm just going to go back now to see if I can actually find out what the measure of angle B is. So if I follow the steps for the TI calculator, I'm going to plug in second sine 25 divided by 65. When you plug in second sine, it automatically opens the first parenthesis. So if you want to, close the end parenthesis and then hit enter. To the nearest degree, you should find that the measure of angle B is 23 degrees. Now let's try to find the measure of angle B using a different trig function. So I'm going to go back up to this original diagram, and I'm still going to use angle B. But this time I want to use tangent of B. So tangent, I need opposite over adjacent. So the tangent of angle B is 25 over 60. If I take the inverse tangent of both sides so that I can find the measure of angle B, I'll have the inverse tangent of 25 over 60 equals the measure of angle B. If I plug that into the calculator following the steps above, but instead this time choosing tangent instead of sine, I'll do the inverse tangent of 25 over 60 and find that the measure of angle B, again to the nearest degree, is 23 degrees. So what do you notice, and what do you think that means? Well, I'm sure you've noticed that the answers are the same. No matter whether I used the sine of angle B in its related relationship or the tangent of angle B and its related relationship, I got 23 degrees for the measure of angle B either way. So it doesn't matter which trig function you use or which ratio you use, your answer will be the same. So let's try another problem. If we want to find the measure of angle Y, remember we always start with the angle we're working from, our reference angle. So the angle Y, we have two sides relative to angle Y. We have the hypotenuse over here is 25, and we have the adjacent over here is 17. Remember your SOHCAHTOA. It's a good idea just to put this on the top of your paper whenever you have problems that will use that acronym. If I have adjacent over hypotenuse, that means I'll be working with cosine. Right? The cosine of y is equal to the adjacent over the hypotenuse. And I have cosine of y is equal to 17 over 25. If I want to get y all by itself, I need to get rid of the trig function. So I'll take the inverse trig function of both sides, and it goes in front of the relationship. So I want the inverse cosine of 17 over 25. And when I plug that into my calculator to the nearest degree, we should all get 47 degrees. We'll also be talking about angle of elevation and angle of depression today, but so these videos don't get too long, I'm going to put that in a separate video.